Okay. So when we talk about partial fractions, it's kind of reversing what you guys are used to. Okay? If I ask you to simplify the following for me. What would you do?
I'll make the bases the same.
Bases? What bases do you see there?
X minus 2.
You mean the denominators? Just messing with you a little bit, okay? So make the denominators the same. And so what would be your lowest common denominator?
X minus 2 times x plus 1.
X minus 2 times?
X plus 1.
Okay. So in other words, I've got to times this by x plus 1. Am I right?
Yes, sir.
And I'm going to times this by x.
Minus 2.
Okay. Okay. So once I've done that, okay, so now it becomes 3 times x plus 1 plus
X minus 2.
okay, which means what?
3x plus 1 plus x minus 2.
Which gives me what?
4x plus 1.
There we go. Easy claps, right? But what if I ask you to reverse this? Huh?
I wouldn't be able to.
That's partial fractions. Okay? So, this process, we've been working on what since grade 9? Okay? When we just started factorization and we looked at those things in the eye, and now all of a sudden, part of, well, what we are going to be looking at now, I mean, is what if I give you a sum that's in this form, and I ask you to break it up into that form? Okay? Now, there is a valid reason why. I just kind of have to say that to you. There is a valid reason why we want to do this. Okay? Or let me explain both sides of the coin. This one, this side, is nice if we've got equations. Let's say I put this thing equal to 0. Okay? Well, that's easy because the only way that a fraction is equal to 0 is if the
numerator is 0.
So then I've got only one solution for x plus 1 equal to 0. Are you with me? So a single fraction is easy when you're working with equations. But, and here's the big but, this thing I can't easily differentiate or integrate. Okay? This thing in this form, we won't be able to do a lot of the later on calculus with. So we've got to be able to kind of reverse this process and say, okay, let's write it in this. So what I'm going to do is I'm going to take something we know to be true and we are going to decompose it into partial fractions so that you see that that's the way it's going to go. So let's say I give you, let's start on this side, 4x plus 1 over x minus 2 x plus 1. If it is in this form, where you've got two different factors in your denominator, okay? What we do, and it's going to kind of feel like cheating. I'm saying this to you straight off. It's going to kind of feel like cheating. But what we're going to do is we are going to say, okay, I'm going to have a bracket that has an x minus 2 in it. Plus, I'm going to have another bracket that has an x plus 1 in it. Okay? But do I know which values must be at the top if I don't have this?
No, sir.
No. So then we're just going to have A and B. Okay? So this is kind of our step one. Is we're going to get it into this kind of form.
Yes, sir.
Now we kind of have an equation now. We've got an equation. So I'm going to multiply straight through with it. LCD. Okay? So I'm going to multiply straight through by x minus 2 and.
X plus 1.
So I'm going to do that straight through. Okay? Once I've done that, what am I going to be left with on the left hand side?
4x plus 1.
And
Ax plus 1 plus b x minus 2.
okay. So I hope that you agree with me, and I'm kind of leading you into this, that left and right hand side is going to be the same no matter what x values I use.
Yes.
So I can choose any x values. But now I'm going to be clever. I'm going to choose x values so that the brackets become 0. Why would I want to do that?
So you just have the a and the b, so you can find out what the a is.
So, what's the first value I'm going to make it?
Minus 1.
So on this side I'm going to be left with 4 times.
Minus 1 plus 1 plus a minus 1 plus 1 b minus 1 minus 2.
Oh my goodness. So, negative 4 plus 1.
Negative 3 equals b negative 3.
You're with me? So, what does b equal to?
1.
Just for interest sake, where do we come from? B must be 1. Oh my goodness, this is awesome. Okay? So what are we going to do now to find A?
X equals 2.
So go for it.
A equals 3.
And what was it originally?
3 over.
Okay, so literally we repeat this process like we did. X is 2. So 4 times 2 plus 1 is equal to A times 2 plus 1 plus B 2 minus 2. So this is 3A is equal to
9.
9 on my head. So A
Equals 3.
is 3. So therefore, okay, 4x plus 1, let's just finalize our sum. 4x plus 1 over x minus 2x plus 1 is equal to 3 over x minus 2, 1 over x plus 1. Ta-da! That is really how simple partial fractions are. Okay? This is really how simple. Now, what is going to happen, I'm saying this to you, we're only going to look at like 2 types of partial fractions. Okay, but there are like 4, 5, or 6 different types. And so at varsity it becomes a lot more complex. But the reason why we are looking for partial fractions, to be able to write it in that form, is simply so that we can actually integrate. So we are going to use integration, which is the reverse of differentiation, to integrate those things. That's actually our biggest use for partial fractions. Because if we had this, like this, you can't just straightforward go and integrate. But the beautiful thing is, let me just share with you, is they would give you this, okay, which is integral. Well, you haven't done that right. Then you would go and do this. Follow this whole process and get just literally one step further for 11 or 12 marks. Really, for 11 or 12 marks. Okay? So it's actually score marks, but you first have to see that you've got to do partial fractions, and then you go that one step further for, I think it's 11 or 12 marks. Okay? So let's go and practice another one. 5x minus 2 over x squared minus x minus 6. Please decompose that into partial fractions for me. Take me step by step through this, Amir. What did you do first of all?
I broke down the denominator into their factors.
Okay, so we factorized, yes. So what are your factors?
X minus 3 and x plus 2.
Okay, fantastic. Now what are we going to put that equal to?
A over x minus 3
A over x minus 3
plus b over x plus 2.
Just for interest sake, say there were 3 factors. What would I have done?
Added a c.
Exactly. Just going to C over whatever your extra factor was. Okay?
Then I multiplied by the denominator.
Okay, so I end up with
5x minus 2
equal to
a times x plus 2 plus b x minus 3.
x minus 3. Okay? There we go.
Then I made x equal I made x minus 2.
Okay? So I chose now my x values. So x is negative 2.
Then it's
Okay. So for those of you that decided that tux is more important than AP maths, okay?
I thought you believe it 10 minutes ago.
I wanted to get the general scope of what is happening, but then people started asking questions and everything got delayed.
So basically what today's lesson is all about is taking a fraction and decomposing it into partial fractions. Okay, this is really simple. Right? It's super simple. Okay? So when the factors are different like here, okay, first of all then I'm going to put just a over x minus 3 and b over x plus 2. Then I multiply by my LCD straight through. And of course things will start dividing away.
Yes, sir.
And then leaving me with,
Okay, so where you get the A and B? You put them there. Or?
yeah, I put them there.
Oh.
Okay, if there was a third one here, I would have run C over whatever the third factor was.
Okay.
Okay? And because left is equal to right, I can actually choose any x values because it will be the same for left as it is for.
Right.
But we're clever enough. Why are we clever?
We can make one of the unknowns. We can take rid of one of the unknowns.
Okay, if I choose my x clever, I'm always going to sit with a 0.
That's the ideal.
Exactly. And the same that side. Okay? So if I make x to be negative 2, I'm sitting here with 5 times negative 2 minus 2, 8 times negative 2 plus 2, plus b negative 2 minus 3. So again, that's going to become 0. That's kind of the whole point of making x something. So I'm going to go negative 10 minus 2, which is negative 12 is equal to b,
5b,
negative
negative 5b.
5b. So b is 12 over 5. Easy clips. Okay?
What is this called? So like, what is this topic?
Partial fractions.
Partial.
Okay? Partial fractions. But just because I used x to be negative 2, okay, tell me, what am I going to make my other x?
Negative, positive 3.
Positive 3. We sit with 5 times 3 minus 2. A negative 3 plus 2. Negative 3 minus, or sorry, positive 3 minus 3, and that's positive 3 that I substitute in. So this gives me 13 equal to 5a. So A is 13 over 5. So what this actually means, Fenway, is that I can take this and write it as 12 over 5 over x minus 3. Okay? Plus 13 over 5 x plus 2. So now what I've done is I've taken a singular fraction, I've decomposed it into partial fractions. It might feel completely useless because what we've done previously was trying to combine fractions the whole time. But last year in the matric finals was the first time that they brought in the integral of ln, which we'll still talk about in the next coming few months, where they asked the question like this, and I've showed this to you already. Integrate that. Now you don't know what the integral means at the moment. Okay, don't stress, we're going to get there. So anyway, we can't integrate that unless we first do this. And then from there, it's one step and you get your answer. But this is a 10 or 11 mark question in the exam. Because you start there, you decompose it, then you put it in there, and then one step further and you get your answer. Okay, that's why they brought in specifically the integral of ln. because the integral of ln makes this a one-step answer. Previously they had partial fractions in and they never asked it because there's no real applications for it until we get to integrals. Okay? So it's 11 marks, 12 marks in the exams. Okay, so if you see this in the exam and you kind of see this next to it, you know it's got to be partial fractions.
Yes.
Now, very important for us is something you need to see, and I didn't say this earlier because I was hiding it. For us to do partial fractions like this, that exponent, the degree in the numerator, I'm going to write it fancy. The degree of the numerator must be smaller than the degree of the denominator. If it is not, then we're going to have to first manipulate it. Okay? So we kind of have to first manipulate it. Now, to manipulate it is a hell of a lot of fun. But it's not always just straightforward. Okay, I'm saying this very clearly. But I know Fenway is bursting at the seams. He would love us to do one of those. All right? Okay. So, let's say I give you one where the denominator is equal to x squared minus 2x plus 1. No, let's not go one that can factorize. Plus 4 over x squared minus 3x. Okay? And I'm asking you to decompose it into partial fractions. So, what is the issue?
Oh, so you said that the degree in the numerator has to be less than the degree in the...
And now it is not. Now it's the same. The problem is if you have ones that are the same, that A over whatever plus B over whatever can't work out. Okay? And just to quickly tell you, Amir, this falls under a much bigger umbrella of the sums that we are going to call rational functions. Because what part of the matric curriculum is drawing this. Okay? And I can instruct you and do a whole term test with one line. Draw this for 45 marks.
How many marks?
45 marks. I won't, don't worry, but I could. Okay? I won't be that nasty. Okay? Because to draw a rational function like this, there's 7 steps you need to go through. Okay? So let me share with you how you can do this. Manipulate the living daylights out of this thing, man. I want to get at the top something that's got an x squared minus 3x in it. Why? Because then I'm going to have that over the x squared minus 3x and they can divide away. Now I have no issues, the x squared is already there, but I can't just subtract 3x. So what must I do in the same breath of air? I've got to add 3x.
What's the thing it's called? You're doing it.
But I was lost here. It's something that this is called.
It was in completing the square.
Yeah, completing the square. So.
And you know what property this is? Something you got taught in grade 7.
Grade 7.
Yes. The identity element.
Identity element.
Yes. The identity element of 0
Oh.
is plus or minus. Because if I plus or minus with 0, I don't change the value of something. Okay? But of course, anyway, there's some more stuff here. There's still a negative 2x minus 4 there. Over the x squared minus 3x. Okay? So at the top, I've got x squared minus 3x plus 3x minus 2x is
Just X.
just x minus 4. And because both of them are over x squared minus 3x, I can write it like that. And therefore that becomes
1.
and now I can actually start with partial fractions. It's because now the degree of the numerator is less than the degree of the denominator. There's some magic I'm doing here. I feel like I completely messed up your mind now.
Okay, so but in that same breath, then could you like do that thing with the denominator for every single thing? Like, could you say x over x squared or minus 3 just for the x squared? So in that case,
Are you talking about put that over that?
yes.
Yes.
Yeah. Okay. So.
Because remember, we did this in grade 8. X squared minus 3x plus 4x cubed over x. I can split this up. As long as I put all of them over the denominator.
Oh, we did do that.
Yes, you did. Now, the only difference is I am choosing carefully so that I can have that divided by that. I'm choosing it. So if that was x squared plus 3 plus 5x, I would have added 5x and subtracted 5x. As long as I do the same thing, adding and subtracting. And now, I can go to this and split this into a over something plus b over something. Over what and over what?
Is that a difference of 2 squares?
What?
No, so I'm looking at it. It's not a difference of 2 squares.
You could say x times x minus 3.
Oh, so x minus 3. Okay? Because this is a, you take that common, x minus 3. So remember now I'm only looking at that. I'm not worried about the 1, that 1 plus means nothing to me. Awesome.
这个文字我是
Oh my head, sorry. That is a negative one. Sorry. Okay. What happens when you don't substitute in paper? Okay. With me? If I make x 0, back one is going to fall away. Now left with 0 minus 4 equal to 0 minus 3, so negative 3a.
How do you get minus 1 to that other answer?
3 minus 4,
Negative 1.
But then, so what about the plus 1? The other plus 1? Or like that's something else?
where is that
The
other?
plus 1, so this
Oh,
is.
this one.
Yeah.
Remember what I said? I'm only worried now about that.
Oh, so you need to. Okay.
Separate things. So what this would mean is that this I can write as 1 plus 4 over 3x minus 1 over 3 x minus 3. Again, if I want to differentiate or integrate, then this is now actually really super simple. Okay? This is going to be one step and I can integrate it. Okay? Now the only thing that's going to come on different at this moment of time is we are only going to look at 2 forms. As I said to Amir, there's about 5 or 6 different forms in calculus. Actually, in that calculus Bible of mine, there's I don't know how many different forms. If you see this in the partial fraction, it's going to look like this. Or if you see that, it's going to look like that. But we are only going to do 2 forms as part of the further studies curriculum. So the first form was if I've got factors here like ax1 minus b. Oh well, let's not make it too complicated. Okay. If I've got like x minus 2, even 2x plus 1, and I can go on, then it's simply going to be a, b, c. Okay? And again, I can carry on. If there's more, I'm going to put in more. But what if I give you something like 2x minus 1 over x squared minus 4x plus 4? First step, what would you do? Factorize, okay? So if I factorize this, I get 2x minus 1 over x minus 2, x minus 2. Okay? What is the problem we're sitting with now?
The A and B.
There's a bit of a problem there. Because if I go and say this is a over x minus 2 and b over x minus 2, I'm going to sit with an issue.
So why is it an issue?
Because if the x is 2, they're both going to be 0.
The x is what?
Okay, so let's try this. If I multiply by the LCD, you're seeing already into the future. I've got 2x minus 1 equal to ax minus 2 plus, you with me? So what value am I going to do for x there?
But it's not gonna work when they go to 0. Okay, so now I see.
So what are we going to do?
I'm going to say both a over x minus 2.
Say again?
I'm going to say a over x minus 2 plus a over x minus 2.
Well, then you get 2a over x minus 2, which is just as big a problem. Because then whatever your a is going to, it could be anything. So there's a very simple solution. Okay? Because if something is in this form, where I have an x minus 2 squared, the ones that we are going to come across is going to decompose into one of them having an x minus 2 in the denominator, and the other one having an x minus 2 squared. Because the beautiful thing what's going to happen now is I'm going to sit with that. Because if I multiply by the LCD, one of them, so not, then you rather go like this. One of them are going to divide away, both of them are going to divide away, leaving me there. So what am I then going to do? X is equal to 2. So that gives me 4 minus 1, which is 3.
Okay, so I get that, but so why? Okay, I know why you put the square there, but are you allowed to? Like, does math allow you to just put the 2 there? Because like,
It is one of those beautiful mathematical tricks. The moment you see the square, then it decomposes into an x minus 2 and an x minus 2 squared. Okay? If it was a 3, a power of 3, I would have gone x minus 2, x minus 2 squared, x minus 2 to the power of 3. Just so that I make sure I cover all my bases. But now I'm sitting with a bit of an issue here. I'm left with this. I'm left with that. Now what?
okay, so does x have to cancel out like the other number?
Well, the problem is, no, it doesn't.
Or just like make x 3, like it'll be all fine.
Yeah, you can. Can I show you something else as well?
Yes.
Remember, the left-hand side must be equal to the...
Right.
So if there's 2x, this must be equal to ax. Because left-hand side has to be equal to... So, because these two have to be equal, a must be 2. And there you've got your answer. Because the coefficient on the left must be the same as the coefficient on the right. But you could just as well. literally any number you want. Let's see if I pick x to be 0. Let's see what I get. 2 times 0 minus 1. 8 times 0 minus 2 plus 3. Negative 1 minus 3 gives me negative 2a.
It's -4. And a equals 2.
I can pick any x value I want. So what is the beautiful thing? Which method am I going to use?
Methods.
Equating left and right, or subbing in values?
Creating.
It's up to you.
Okay, it's the faster way to do it. So.
If left is right, if there's a 2x, then there also has to be 2x. That's the only way. So a must be 2. This is the fastest way. Okay, this is by far the fastest way to do it. So you choose. And this gentleman is partial fractions. Okay? It really is super simple. We are going to get two forms. We're going to get one like this where the fractions are different. The factors are different. Or we are going to get ones where the factors are the same. And then it's going to be a over x minus 3, x minus 3 squared. So those are the options that you are going to be asked.
So those are the two scenarios.
Yeah. That you are going, that's part of the curriculum. Okay? It's not the only two that are available. At varsity, sometimes it becomes quite tricky because it's about 6 or 7 that I can think off the top of my
The
head.
one you were doing, so that had ax plus b. What are the other ones?
Say again?
The one you were doing, so you said ax plus b, but you said decided to not do it because you said it was too hard. So
Yeah.
what was that one? So was that part, like also part of the curriculum?
No. No. Look, as I say, there's ones where what if I combine these two? Or what if things cancel out that, and then does it give you a solution? And then you can try different variations to play around until you get something that works. Okay? But this is partial fractions. Again, it's part of the curriculum so that we can get to integrating it. Okay? And this is now going to lead us to next week, where we are going to start looking at, where we are in the, not necessarily next week, but in the coming weeks, rational functions. Okay? Differentiation, integration of rational functions. Okay? Because we are going to look at we're going to look at interesting things like asymptotes that are skewed. Okay? How do they look? How does it work? When does a graph cross its asymptote? Okay? Those things that your teacher says can never happen in coordinates. We are going to explore that. And that's it for today.
Thank you.
It's a pleasure.